Hi, I'm Jake Neal, Project Manager for Maxwell. Today, I, along with my 4 colleagues, will be going over Cycle 1.
Starting off with the intro, Maxwell is an animatronic safety administrator commonly found at the entrance of many campus buildings. As an animatronic figure, he'll sit behind a desk and he'll be able to answer any generic questions that guests and visitors may have. For example, a guest could ask where the nearest restroom is or where this specific professor's office is. He'll be able to answer these questions through motion with his limbs, and he'll also have an on-desk screen. But most importantly, Maxwell will react to severe weather, fire threats, and sounds of gunfire. In case of a severe weather warning, he'll tell guests where the nearest severe weather shelter area is. In terms of a fire, he'll provide access to the nearest exits, and when there are sounds of gunfire, Maxwell will be able to alert the authorities.
For the executive summary, I will be touching on these points behind me. For the base, we've redesigned it to be less bulky. The desk has also been redesigned to allow for portability and cheaper materials. The face, we've hit some snags because of multitasking, but that's also pointed out a lot of issues that we need to work on in a more big picture way of running Maxwell. For the acoustic surveillance, we've analyzed gunshot signatures and better understand the wave profile that they have. For the website and GUI, we've done a ton of advancements on that and are completely ready to move forward with interacting with an actual robot. The budget will also be covered by Cameron, but it looks like we are projected to be well below budget.
Now, moving on to the portable cart. Maxwell will be situated on top of a cart. Previously, we've had designed a stand that was made out of PVC pipe. That stand, however, was too big and took up too much floor space, so we redesigned it to look like this. What we have here is a wooden structure. It has a much reduced surface area, and it's heavy in order to lower the center of mass. We wanted to have the center of mass low so that it wouldn't tip over while moving his limbs. Eventually, we would like to include caster wheels for mobility. The caster wheels, of course, would have locks on the bottom of them. Once Maxwell is situated in his specific spot, those locks will be activated so that he wouldn't move anymore.
Hello, my name is Adam Paul, and I will be discussing the portability of the desk around Maxwell. As you can see here, there's going to be 1/2 inch thick plywood on the top. There's going to be 2x4s running along the length of the desk to provide sturdiness. There will be 2x2s cut from the 2x4s to act as the legs of the desk. The section where they will separate into 2 different pieces is along this line right here. So this is one desk and this is a separate desk. One of the desks will be curved to allow easier access for the kiosk that will be at this desk. This is the underneath side of the 2 desks. For reference, this is the point where this desk separates from that desk. This desk will have 4 legs, as shown. This is with the current height of the legs, which are still in question, so the legs might need to be resituated. There's a slight tilt to this to allow the legs to fold in properly. On this desk, there will only be 3 legs. We believe that the desk will remain sturdy even with 3 legs, as not too much weight will be added onto it. If a 4th leg needs to be added, it would just go right next to it and then fold back down as well. To discuss campus safety integration, there will be an emergency blue light located on the desk. We have not made contact with campus safety at this point to figure out our limitations on what we can do involving the blue light or the kind of support that we can receive from them with the blue light. So the options past that are to create our own version of a blue light. Currently, I've been looking through some ideas of voice over IP for calling 911. Some of these issues that involve this, though, are if you call 911 using voice over IP, they do not know your geographical location because the location does not pass through with the IP, and your IP may change depending on the just general calling. In addition, as well, is going to be the AU alert system. The kiosk will have downloaded the AU alert desktop program so that when Auburn Campus Safety sends out an alert, the kiosk will be overridden and display the AU alert. There will also be a scrolling bar LED screen attached, as there are examples around campus. As previously stated, we still need to get in touch with campus safety on being able to utilize one of those.
To continue on, the face has the same design that we had at the beginning of the cycle. We're using an Adafruit 32 by 32 RGB LED array. The face, as you can see to the right, is somewhat of a prototype of keeping it very simplistic so that it's very visually appealing, but also keeping it simplistic because it's just easier on our end to be able to draw that frame to frame as he speaks. To continue, the face issue that we've run into is dealing with multitasking. To explain that better, I've come up with an example that's very analogous to the problem we're trying to solve, which is a volume soundbar. For starters, you have your source, such as an iPod or a record player, what have you, and that will pump in the sound or the music, whatever it is, into the system you're working with. And that gets split off into two sections. One goes as an auxiliary output to a speaker to play the sound so that everyone around can hear it. The other half of this is a sound analysis that takes in the sound wave, quantizes it into levels to say how high the LED bars should go. The key point of this is that most systems only do the sound analysis aspect. The initial sound source file is coming from an external source with its own processor. Our problem is that we are trying to be both the source of the sound and the sound analyzer. To do that takes a lot of processing power, and to this point we have not found a solution to allow for it to play sound while doing another task. Options that we are considering is splitting the task between multiple processors, multiple Raspberry Pis, for instance.
Hi, I'm Peyton Nelson, and I'll be talking about the acoustic sensor. So, a gunshot is incredibly loud, especially indoors. Even the lowest caliber bullets are upwards of 140 decibels. Also, the waveform is incredibly sharp. If you see here, it jumps from ambient noise all the way up to its peak, and then there are reverberations around the room. So all we need to be able to do is to detect that peak, which nothing else in Brown Hall should be able to match. So we can compute the waveform on a Raspberry Pi and figure it out that way, but that requires a bunch of processing power, which is something we're already running low on thanks to the digital face. So you can get a simple solution by adding in a hardware rectifier, similar to AC to DC. And that will detect this peak and give a DC output at about that voltage level. A few models of microphones actually have this built in, primarily this one at the bottom right over here. If you see that has a potentiometer, which you can adjust to trigger an LED, also shown there, whenever it hits a certain decibel level. So once we begin testing with these, we'll adjust the gain on it until it hits that specific level at 140 decibels, or about there. For powering Maxwell, we're looking at two different options. Both of them start with an uninterruptible power supply. From there, it connects to a 12 volt, 3 amp rated power cord. In this first option, that cord goes from a 7 volt, goes to a 7 volt bridge rectifier, as well as to a 5 volt bridge rectifier, and each of those will power different loads. The 12 volt and 7 volt will each be the servos, and the 5 volt will be the Raspberry Pis. The second option we're looking at is a little more simple. It involves getting a used power supply unit from a computer, and all these leads on it actually have 12 volt and 5 volt leads on them. And we can cross those to get a 7 volt lead as well. And the primary advantage of this is that it's a little bit cheaper if we buy from the right places, and there's plenty of leads for Maxwell to tie into without us having to solder.
One of the main things we've done in Cycle 1 is transition from Wix API, which is a very loose, kind of easy to work with, but it doesn't let you do much editor for our website, to Wix Advanced Editor. Wix Advanced Editor allows me to enable things like Corvid by Wix, which allows me to create JavaScript functions, as well as lock pages down, create UIs, that kind of thing. So in that line of things, we also created a UI for Maxwell on our website. It's in a locked page that's hidden from normal users. We also created JavaScript backend functions. These allow us to do things like when a button is hit, we can communicate with our device. I also created on-click functions to allow it to interact with the backend functions when you click a button. And you can actually see example of that over here. That's our button, and it's kind of small, but you can see it actually has some code at the bottom there. That is our on-click function. These actions are sent with email via SendGrid. SendGrid is a service that allows businesses to send emails to all their customers and to take data from forms. We're using it for free since we're a small project, and we can then also create tables to select different actions. So our website layout, we'll just talk about that for a minute here. We have a home page. On it we have about us, about Maxwell, and we have links to the other sections of our website. Our blog has our weekly updates as well as website updates that I publish kind of bi-weekly. Forum we have for discussions, not too much goes on there. We have our movements page, and we'll see more on that in a minute. That's Maxwell's hidden UI. We'll have user pages. These contain profiles, settings data, posts, and all of that. We also have a donations page that allows people to donate any amount of money they want via PayPal or card. So we're going to play our UI here. So this is an example of our UI working properly. So what I'm going to do here in a second is we're going to select something from this table. This is a drop-down table. So we're going to take the mouse, we're going to click on that, and it'll show us what actions we can command on Maxwell. Now I'm going to select bow as our actions. This will cause Maxwell to lean forward. So now that I've selected that, what we're going to do is we're going to hit the submit button. When we hit the submit button, it'll trigger those back-end functions I was talking about, and we'll go over to our email, and we can see, once we get in our email, that we've actually received that command directly. Next, we're going to talk about our budget. Of our original $3,000 all in, our current analysis shows that we're going to use approximately $2,650. These include things like safety features, which make up approximately a third of the total cost. Under that, you can see 800 of that are safety features assorted. That includes anything that campus safety specifies that we may need. This could be LED scrolling bars, it could be blue lights, it could be anything. So that's why we've dedicated that money to that. It also includes things like test and evaluation and microphones as well. Other than that, servos make up pretty much an additional third of the budget. It's actually a little higher than a third. This is because servos are very expensive and we'll need several of them to make Maxwell really run well. Other than that, you could see that we're not really spending that much in here for other things. 200 for screens. Computers, we're gonna spend like 70. That's approximately 2 Raspberry Pis. And most other costs are pretty low overall. So that's all we have for that.
In conclusion, we've done a lot of work in Cycle 1, but there's still a lot of work left to be done in Cycle 2. For starters, we're going to complete the desk. We'll be working with John Tennant, where he's going to assemble the materials and complete the desk for us. For the overall brain of Maxwell, we've decided to shift our focus there rather than finish the face first, as the face has pointed out some issues that need to be attended to. For the acoustic surveillance, we'd like to make a prototype so that we can test it and then implement it into the build. For the user interface, we're going to work on a lot of features as they pertain to the overall brain. As for campus safety, we would like to form a line of communication so that we can figure out if we're going to use their components or if we're going to have to create our own versions. Thank you.